Hello everyone. Today we are going to discuss LeetCode Twosome. This is the first question that appears on the 75 LeetCode questions curated list. So yeah, let me start sharing my screen. Before I dive deep into the question, I would like to give a run through of these 8 steps that I like to follow for each interview question. So these 8 steps are basically a good way to go through an interview question so that the interviewer is satisfied and you have a clear communication with the interviewer. So the first step is always read and understand the question as clearly as possible and try to understand any edge cases you have there. Second is, this is very important. You need to figure out what's the input of the question is. So basically, if you look at it, in this twosome, the input is an array of integer. Sorry, an array of integer, an array of integer, an array of integer. So yeah, you should clarify in each question first. All right, or as an input, I'm going to get an array of integer output. To some questions, we are outputting a vector of only 2 numbers. So vector of int will be an output here. So it's always a good thing to clarify before you actually dive deep into the question. Then once you're done with that, understood the question, then try create as many as test cases and edge cases as you can, and then try to run do this on your own and try to run a common algorithm on all those common algorithm that covers all those test and edge cases, so that you don't miss any edge cases and test cases. So, this is always the best case, the best way to do it, because if you miss any edge cases and then your algorithm fails for it, and if you haven't caught it yourself, then it's a bad image to your interviewer. So yeah, please do that. Once you're done with that, try to figure out a brute force solution, like the worst case, like with worst time complexity you can imagine. But it always solves all the edge cases. So once you're done with that, try to simplify it by efficient solution. If you have done something similar in the past with the same algorithm, you won't have that hard time figuring out an efficient solution. But yeah, sometimes you might face a question of which efficient solution you haven't done any pattern like that before. So yeah, in that case, we can't do much except keep trying. But yeah, once you're done with efficient solution, try to write a pseudocode on your paper first before you actually run the code in IDE, because that way it's write the code and then run some test cases on that and figure out that it's done. And only write the code in IDE once you are, I would say 70-80% sure that this code should work. But yeah, okay, so let's dive deep into LeetCode Twosome. Let me use this. So yeah, the question says given an array of integer nums. So basically, one thing we can do is like the input is array of integers, and then an integer target. These are the 2 method parameters that will be there. Return indices of 2 numbers so that they add up to target. So I think we can say here is input is a vector of int and a target, integer target, and output is a vector of int itself. So once you do that, now we keep reading the question. You may assume that each input would have exactly one solution. All right, I think that's a very good thing to say, that each input would have exactly one solution. This means, like, let's say if there are any two possible solutions, let's say, like if you want to look for a target which is 9, then either 7 or 2 or 5 and 4 can be present later. But as soon as we find it, we can return it. So that's a good way. That we get conclusion that as soon as we find the 2 pairs, we can just return their indices. And you may not use the same element twice. All right. That means that if you're looking for 9, let's say 8, then you cannot just use 4 and 4. So okay. So these are the 2 edge cases, I would say. Let me highlight them with some different color. Let's say this. I wonder why. Very relevant way. But let me see. It's right here. Where was it? We will not use the same element twice. Okay. Now let's look at so first 3 steps are done. We know the input, we know output, and we know multiple test cases. We understood the question. Now the 4th step is this one. Multiple test cases, edge cases. So yeah, if we think about it, let's write down the multiple edge cases and test cases. One is, let's say there's an empty vector given. In that case, we just want to return an empty vector too. If there's only one character, let's say 1, and let's say this is the and this is a vector, this is nums, this is target, and you want 3, then in this case also nothing is possible, because the edge case said earlier, if you read, you may not use the same element twice, this one. So we can just say, yeah, return an empty array in this case too. Now as soon as it's 1 or 2 exist, and let's say 3, then we will return 0 and 1, because if you see in this question, they want us to return the indices of the two numbers. So yeah, null, single element, and any element more than 1 are the 3 cases. Now the thing is that either you can, the next cases will be like, let's say 1 and 2, and nums given is like 5. In this case, we don't find anything. So in this case, you should always talk to interviewer and say, all right, what if I don't find the sum at all? What do you want me to return? So in that case, return a null. I would say empty. Null is never a good way to return. And then what if you actually find it, let's say 6, and then you have 1, 2, and 4, then you just return the value of 1, 2, the vector of 1, 2. So yeah, now there are multiple ways to do it. The brute force, now after we have done these cases and see, yeah, edge cases and everything is done, now the brute force solution for this is just iterate the loop twice, and then let's say this is, let's take this example, 2, 7, 11, 5, and 9. So 2, 7, 11, 5, and we are looking for 9. So what we can do is like do an like for I equals to 0, I less than, this is nums. So nums dot size I plus plus, and then we can go for int j is equals to I plus 1, j less than nums dot size j plus plus. And what you can do here is just say if nums of I plus nums of j is equals to target, then you just do a return, create a vector of int, and then just put I comma j in it and return. But this one will be run n times. Let me take another color. This loop will be run n times. This loop will be run n minus 1 time, because it always starts from. But what we're going to do is like 2, 7, 11, 15. I will be this, then j will go over here. I will become 7, then j will go over rest 11. Then so basically, the time complexity of this one will be n star n minus 1, which is n square minus n, and the bigger term out of this is n square. So big of n square will be the time complexity. In this case, the space complexity will be big of 1, because if you see, like this is the code here, we literally did not have to create anything, any variable. We are just returning a vector. So that's a brute force. Now, once you have done this and mentioned this to your interviewer, the next thing you want to do is efficient solution. So in this way, efficient solution, what do I mean? Like brute force gives us big of n squared. So you have to do less than this. So you have to do it big of at logarithmic n or big of n. So these are the two things that are smaller than n squared. So if you can do a question in this, it's a good way. So if you see, yeah, so the way I do it in big of n is, let me take another pen here, this method. So I like to use a hash map. Hash map is insertion and find. These are big of 1 time in a hash map. So what my code is going to do is like, I'm going to iterate through this code 2, 7, 11, 5 only once. And while I iterate, I'll keep pushing these values as in the map. So let's say I look at 2. I have like, I'm going to do this. I have target 9. What I'm going to do for when I is equals to 0, I'll say to find number is 9 minus 2. Then I'm going to check in the map, does 7 exist? If it doesn't, then I'm going to move forward and put 2 and 0. 2 is here the nums I, and here is I. So this way what I'm going to do is like each number with its corresponding index. So then when I is equals to 1, to find will become 9 minus 7, which will become 2. Now I'm going to go and check and look at the map. 2 exists. This basically, so what's going to happen is here is like, all right, we wanted to find target 9. 7 already exists at I is equals to 1. And if we can figure out 2 in the previous array already exists, then yeah, we just return the indexes. So here we can just return 1 comma 0. And then this is the answer. Now let's say, what if 2 was here and not here? So what could have happened is like, let's say this becomes 2, this becomes 5. So what we're gonna do, this will become 5, 0. We'll keep going, we'll do 7, 1. We'll keep going, we'll do 11, 2. And then once we come at, let's do I is equals to 0, 1, 2, 3. Then nums I is equals to 2. Then to find will be target minus nums I, which is 9 minus 2, which becomes 7. Now we're gonna go and look at this map. 7 exists as 1. So then we are gonna return 1, which is the index of 7, and I, which is 2 in this case. So yeah, what I'm trying to suggest here is like, iterate through the list only once and keep storing in a map, and map find and insertion are big of 1. So our algorithm will be a big of n. Let me write the code real quick here. So what we can do here is, in C++, we can say MP, and then yeah, before the code, actually, yeah, now let's think about it. Now what we're gonna do is iterate int I is equals to 0, I less than nums dot size I plus plus. Then you can just say int to find is equals to target minus nums I. And then you can do an auto iterator is equals to map dot find to find. If iterator is returned as non-null, let's do like if iterator is not is equals to mp dot end. In C++, this find method will return the iterator pointing to the value if it's find the value, or else it will point at map.end. So this code means that iterator is not equals to map.end. That means iterator points to the exact value. So what we're going to do here is return a vector of int, and we can just do, now we have to return indices, so we can have to do I and it's second. The reason being this is, if you see in the map, we are storing number and then the indices. So it iterator points here. First of iterator is this, second is this. So whenever we find the number, we have to return this one. So it is second. If this happens, this is good. If it is not equals to mapend, else, that means it is equals to mapend. That means we didn't find the number. So we'll be like map nums I is equals to I. This will keep pushing. And let's see, else started here and for started here. And worst case, if we do not find anything, we're gonna return vector of int, an empty vector. and this will be the code. Now you need to think if these are covering edge cases. So think about it. If only a null empty vector is coming, this code will be executed. This will never be executed, and you'll return an empty, which works for us. If only one is executed, think about it. This will execute it. This code will be executed, but only for once. Like I equal to 0, and it will never find because map will always be null. And then it will return this, which works for us. Anything about more than 2, like let's say 1, 2. If we find it, we're going to return it. If not, then we'll just return a null. So I think this code should work.